Hello everyone, am I audible? Sorry for delay. Share the screen. Wait. I just shared the screen with all of you. Note. Can you see the screen? Okay. So, what's the tutorial number today? Tutorial 5. Am I right? Okay. So, first of all, today we're going to discuss about the inner product space. Who is there? I don't know why students come late. It's already late and okay, how many students are there total? 14. Yes. Harshita, can you please mute your mic? Yes. So we are discussing about the inner product space. So what is an inner product space? So it's just a wait. So you know all about the vector space V, right? And it is defined over field F. That you already know. I don't know. So we define this function from V cross V to F. Okay, and how do we define it? So there is a function denoted by this thing over here. Let me. So this is a function. This is called as inner product. If so, this is just a function from V by V to F. V Cartesian product of V or with F to F, anyways. So what does it satisfies? So it's an inner product if for all x, what happens? For all x, y in V, let's say z in V, for all x, y, z in V, and a, b in the field F, you have first property called as conjugate symmetry. So what does happen in that? X inner product with y is y inner product with x. This is this. So it's a conjugate. Everyone knows what is conjugate? Yes. Second is linearity. So what is in the linearity is that it's linear in the first component axz plus byz. That's called as linearity in first argument. So that's it's linear in first argument. So that's true, and so it's yeah, okay. So it's just a vector space with an inner product. So we define inner product as a map, and it satisfies following three properties. Third one is, who is there? Again, there are so many students waiting. Wait, very tired. Okay. Third property is the positive definiteness. Is that XX inner product is greater than 0 if, okay, is this clear to everyone? Three properties. Yes, so that is the definition of inner product. Okay, now we have some questions that you're gonna try now. Wait a second. So what is the question we have? Assignment 5 is, I discussed the, wait a second. Am I ahead of, or I have, I think I go, have I jumped off a lot, or I think I jumped off so high. It's not what I'm going to discuss today. Sorry. So this is inner product anyways, but we are going to discuss assignment number 5. Yes. But it will be used later, so you just use this definition before. So I just gone to assignment 8. Please remind me of what I'm teaching. Okay. So for this tutorial, we are going to discuss about the linear transformations and some questions on it. So what is a linear transformation? So T is a linear transformation from vector space V to W if TV plus W is TV plus TW for all VW in V, and TV T alpha V is alpha TV F and V in V. So these two properties are satisfied, then T is linear transformation. So you have to try some questions on that. Okay. So if you, so the question 1 is, check if T2 is identity transformation or not. T is from R2 to. So the first question is, first part is Txy is x minus y. Yes, and okay, and about x equal y line. Okay, just check this one. So in this case, if it is linear, if T2 is identity or not, you have to check. Another thing you have to check is question, does there exist a linear transformation T from R2 to R2 such that T1 minus 1 is 2 minus 3 and T minus 1 1 is minus 3 2. So does there exist such type of linear transformation? So just try these two questions for 10 minutes and then let me know. We already discussed about the linear transformation today. because assignment 5 is based on linear transformations only. So we do have a couple of questions. Just check. Yes, have you tried that? Sorry for delay. Yes, what is the first one? Have you tried? So txy is x minus y. So t2, so we want to check t2xy, so it is just t composed with txy, and that is tx minus y, and that is x minus y. So that is xy. So it means that t2 is identity. Is it clear? The next question is, does there exist a linear transformation t1 minus 1 and t minus 1 1 is this? So second question is, t1 minus 1 is 2 minus 3 and t minus 1 1 is minus 3 2. So how do you do that? So the first, you can derive the second equation from the first one. So you only have t1 minus 1 is equal to 2 minus 3. So how do you do that? Does there exist a linear transformation like this? Anyone? How can you solve, like, how will you solve this? So what is the basis of, okay, so there is only, t is defined only at one point, but you need to define the t at 2 points. So you can check, so t1 minus 1 is 2 minus 3, and you can define t of 1 2 1 4. Yes, and so what we have to do is to define a linear transformation such that it is defined on the basis elements. Wait, so here just choose basis, choose element from R2. It's linearly independent from 1 minus 1. So we want to choose an element from R2 such that it's linearly independent from 1 minus 1. So 1 2 is, you can check that 1 2 1 minus 1 forms basis R2. So if beta is a basis, then t beta should be a basis. So you can define t beta 2, this beta 1, beta 2 as something, let's say gamma 2 linearly independent. So you can define a linear transformation like this. Linearly independent from 2 minus 3. Is it clear to everyone? Yes. So today we are going to discuss about only linear transformations. Then we do have, so I will solve some more questions based on that. Yes, so the next question is, okay. The next question I can write. Yes, there is one thing that I want to share, like coordinate representation is happening. So Px is given by 5 plus 7x minus 3x square, right? So we have to represent this as a coordinate representation to the basis. So basis is given to you as so you have to find so how to coordinate representation to back to this as so Px can be written as a linear combination of a 2 plus 3x and c times 5 plus x square, right? Then Px is given as 5 plus 7 minus 3x square, and here you can take a plus 2b plus 5c plus a plus 3b plus c plus a plus 3b plus c. Is it correct? A plus no, a plus c. So you can solve, you can compare both sides, then you get a plus 2b plus 5c is 5, a plus 3b plus c is 7, a plus c is minus 3, and solve this system of equation to get a, b, and c, right? So that will be your, that's coordinate representation with respect to set. Okay, is it clear? Is it clear to everyone? Okay.
Yes, sir.
Okay, so that is the coordinate representation. If you, I think there is similar question, this is the same, I think, in the assignment, you can try that. Yes, so next question that I want to let you do, let's do the next question. You should try from your assignment. So V is a vector space, dimension of V is 3, it's given to you. T is from V to V is a linear transformation. T of V1 is 1 minus 2 1. T of V2 is 0 1 2, and T of V3 is 1 minus 1 3. Then check T V1 plus V2 is TV2. T V1 plus V2 plus V3 is 0, or T V1 plus V2 is TV2. Can you check this and tell me? I write another question as well, but please do that. Check it. Yes, have you tried that? What are the answers? So the first one is TV1 plus V2. That you can check. Is that 1 minus 1 and 3? Is that same as this? Yes, it is same as, it's not same as TV2. Similarly, you can check. So TV1 plus V2, which property use? Linearity. And similarly, you do have TV1 plus V3 equal TV2. Is it true? You can use linearity again. Then it is um, minus 3, and no, it's not same as TV2. And the third one, second one, so this is not same, this is not same, and this is not true. I think so. Yes. Okay. So all options were not correct. Is that? Wait, TV1 plus TV2. Yes. TV3. Okay. I think that first option is TV3, so it should be correct. Okay. The next question that I want to write is a typical one, maybe. Okay, so what kind of thing? Don't have more questions. So if you have something, so some better on this. So if you have A from a matrix from R2 to R2 defined by a linear transformation, 1 1 is 2 1, and A 1 0 is 0 3. Then how do you find the matrix of linear transformation in the basis? So basis is 1 1 1 0. Okay, so you have to find matrix of linear transformation of a basis 1 1 and 1 0. So what's the linear matrix of linear transformation in the basis? Anyone? Can anyone tell me? How do you do that? So you have to write, since A11 is 2 1. So you have to write as linear combination of 1 1 and 1 0. Okay. So how do you write? 1 1 plus 1 0. Okay. You can write like this. And 1 0 is 0 3. And this you can write 0 3. This you can write like this. How do you write like this? 0 times 1 1. Wait. 3 times 1 1 plus minus 3 times 1 0. Okay. So it is written as 0. So what you write? So what is the matrix? You just flip the coefficients. So in this case, the coefficients are 1 1, and in this case the coefficient are 3 minus 3. So that is your matrix. Matrix of linear transformation. So if you have to find the matrix of linear transformation, you can use these steps. So this is one thing. Another thing that I want to tell you is you know how to compose, that I've already told. Okay, we can try some another question then. So I think I've covered most of the things on linear transformation, and that's enough. Yes, so what is the null space of linear transformation? If you remember, linear transformation. What is the null space? X such that Tx is 0. So if you have to find the null space, you can find easily with the definition. And range space is Tx such that X is in V. Right. Okay, so this is this, and null space of T with, so T, every finite dimensional, oh sorry, so in, I would say that every matrix can be associated with a linear transformation, and every linear transformation can be associated to a matrix. So that is a vice versa. That's true with respect to any basis. And okay, yes, that I want to tell. So if you see any matrix, then you can just transform it to a linear transformation, or any linear transformation to a matrix. Yes, so I think that's enough for today. Maybe for we have covered linear transformations. Then we will discuss. I think in the assignment 6 uh, we do have some different questions. That's the same on linear transformation, but we will check about one-to-one onto invertibility. Yes. So in the next two assignments also you do have. So in the next assignment you have one-to-one onto and invertibility of linear transformations, and in another next to next you have orthogonality. So we will discuss till this in the second. Yeah, thank you. If anyone has any questions, they can ask. Okay. I think I have already shared the screen, or yes. Is it clear to everyone? Yes.
Sir,
Anyone has
can
any?
you explain the first
Yes.
question?
Which question?
At starting first slide, first
Uh,
one, linear transformation.
yes, yes. This one.
Yes, sir,
Which?
that one.
This one. Yeah.
Come on, this one is equal. No, not that one. The
Second
below
one.
one. Ah,
Yes.
yes.
So in this question, you have to prove that there exists a linear transformation or not. Okay. So in this
Yes, sir.
question, you are given the value of the t on a particular point, right? And the second value is also given, but you can derive the second value from the first one, right?
Yes, sir. Yes, sir.
Yes. So what you do is you select a basis. You want to frame a basis for R2, and t is defined only at one point. So you can define the t on another point, right? Which is linearly independent from 1 minus 1. So I've selected 1, 2. Okay.
Okay, sir.
So so if you are given if you are given the linear transformation, sorry, a function only at one point, then you can define it on another point which is linearly independent from the first point, and which forms a and the set together forms a basis of R2, right? And there is a theorem that if you define such functions on the basis elements, then you would say that T is a linear transformation. Okay.
Okay, sir. Okay, sir.
Yeah.
Yes, thank you.
Yes. Any other queries? Yes. I just ask by names. Bhagya, Pragya, Shruti, Mai, Harshita. Any queries? Meenakshi. Is it clear?
Yes, sir.
Okay.
Yes, sir.
In your lectures, what's going on? Is it the same or different one?
Yes, sir. This one.
Okay. Have you done your assignment questions all or not? I hope it is clear. You can try more questions on the topic linear transformation from your books. There
Sir,
are books.
can you give a hint on the question assignment given? Question number 6, based
Question
on
number.
polynomial.
Wait a second. Question number 6. Wait. Okay, so in the question number 6, you have the vector space of all real polynomials of degree less than equal to n. Then you have two statements. There exists a linear transformation such that range t equals to kernel t, range t. So you have to use the rank nullity theorem, okay? I have
Yes,
discussed this
sir.
before. Yeah. So you have to check using rank nullity theorem. If it is failing over that, then it's not. Yeah. Just verify that in this case. Thank you.